All right, we are going to do some practice with some compound unit analysis. So this is when we have measurements that either have ratio or fractions of units. For example, if we said the speed limit on many highways, it's 55 miles per hour. So that could be written as miles per hour. And if we wanted to convert that to meters per second, then we would need to, there, I just rewrote that a little nicer. If we say 55 miles per hour, that means we're traveling 55 miles in 1 hour. And so I'm just going to put a 1 right there. So miles per hour is also like saying 55 miles per 1 hour. Now, I'm told here that 1 mile is equal to 1,609.3 meters. That's an exact unit of conversion, so we don't use this when it comes to significant figures. We started with 55 miles per hour, so 2 significant figures. We'll end with 2, but I have miles on top here, so I need to have the miles, the 1 mile on the bottom. So for every 1 mile, there's 1609.3 meters. So that will get rid of my miles. And then next, we got to get rid of the hours because we want per second. So I need to have hours on top and seconds on the bottom. And for 1 hour, there's 60 minutes, and then in 60 minutes, in 1 minute, there's 60 seconds. So 60 times 60 is 3,600 seconds. So now all we need to do is multiply across and divide going down. And my calculator says 24.586. And I'm going to round that. Like I said, we started with 2 numbers here, so I'm going to round that to 2. So we're going to say 25 meters per second. So that's, and notice, hours I had to get rid of. So hours and hours cancel out because they're diagonal from each other, leaving me with the only unit on top is meters and the only unit on the bottom is seconds. That's how we get meters per second. Let's do another one. Let's say we have a motorcycle that's traveling at 105 kilometers per hour. And again, we can put a 1 there if you want to, or leave the 1 off. It doesn't matter. We want to know that speed in meters per second. So we're told that for every 1 kilometer is 1,000 meters, and that in 1 hour there's 3,600 seconds. It doesn't matter which one you start with first, as long as the kilometers is on the bottom. So if I want to start with going from kilometers to meters, that's fine. Or we start with this guy, and then my hours would need to be on top. I'm just going to start with the kilometers to meters. So kilometers, meters, and it tells me that 1 kilometer is 1,000 meters. So that gets rid of that. And then the second one I'm going to do, again, I got to get rid of hours, so I got to have hours on top. And it tells me that 1 hour is 3,600 seconds. Why isn't it writing? So hours and hours cancels, again, leaving me with just meters per second. And then let's get rid of my sloppy handwriting there. And we can see that we would get 29.2 meters per second. Here's another one where we are given an automobile battery contains 2,346 grams of acid. And we know the density, which is 1.84 grams per milliliter. So I'm just going to write 1.84 grams per milliliter. That means 1 milliliter, 1.84 grams. And again, this is a ratio. So we could say that 1 milliliter over 1.84 grams. Either or. It's like saying 1 kilometer. In 1 kilometer, there's 1,000 meters, or 1,000 meters is equivalent to 1 kilometer. So I can just flip this around. Now we're told that we have 2,346 grams of acid. Now I want to know what volume in milliliters of acid are in this automobile battery. So I want just milliliters. I want to get rid of grams. So I can do that by having grams at the bottom to cancel out the other gram and the milliliter on top. So I want to use this ratio, which I've given in my density. So 1 milliliter, 1.84 grams. And if we pause real quick to check with our calculator, we should get, grams and grams cancel, 127.2. And again, we started with 3 significant figures. So I'm going to round that to 127 milliliters. Moving on, looking at the percent concept. The percent is looking at a single quantity compared to the entire sample. A percent is looking at parts per 100, and we can calculate percent by doing that part divided by the total and then timesing it by 100%. So let's say if I said 25%, I could say that that's 25 over 100. 10% can be 10 over 100. Because if I did 25 divided by 100 and then times that by 100, it'd be 25%. So you can work backwards. So here's an example where I'm told the percentage that the Earth and the Moon have a similar composition and they each contain 4.7% iron. So I'm told the percentage, 4.7%, and it wants to know the mass of the iron. So it wants to know the part of the Moon or the Earth, whatever, the part where we have a lunar sample, the lunar sample that weighs 92 grams. So we want to know that part, this piece. So what divided by 92 gives me 4.7%? Well, remember, I'm just going to erase this here, that 4.7%, remember, is the same as saying 4.7 over 100. So we can cross multiply here to find our missing piece. So I'm going to say 92 times 4.7 and then divide it by 100. So it's that bow tie method. We're going to do this and then divide by 100. And let's plug it into our calculator to see what we get. And we should get, our part should be 4.324 grams. So we just had to work backwards a little bit to get there. How about this? Bronze is an alloy, I should say alloy, of copper and tin. If a sample of bronze contains 79.2 grams of copper and 10.8 grams of tin, what is the percent copper in bronze? So I want to know the copper part. So I'm going to say my part of copper, which that's my part, over the whole. So then I need to add these two together. So let's do my part. This is my copper over the whole copper and tin, times it by 100, and we should get 88.0%.